Yes, yes.
Is
Yeah, yeah,
everyone
Akash, you can
set?
start. Uh, Suresh, Gopi, Rajanna, are you there? Pavan, Vinay is there. You can just, yeah, Akash, you can start, I think so. Everyone have joined. They would just raise their hands.
Okay, okay. But one thing is only meeting organizers and presenters can share. I cannot share my screen. Do you know why?
Uh, Dincy, are you there?
I am here. Sorry, I think Dincy, are you there? Sorry. What is
Sorry,
that?
ma'am. Yes, ma'am, I'm there. I'll make them the present.
Okay.
Okay.
Yeah, thank you. I'm sharing my screen, okay? Is it visible now?
Yeah.
Yes, sir.
Yeah, and don't call me sir. Okay, so basically we are starting from the problem statement. Okay, so the problem statement is detection for default credit card, default of credit card. So do you know what is default of credit card? I mean, when a payment default occurs, something like that. Okay, so basically a payment default for the credit card is occurs when like you fail to pay the due amount on the credit card for a few consecutive months. Okay, so basically it's not like 1 month or 2 month. Basically it is considering we consider that 6 months fail, then we send the notice of credit card default. Okay, so our problem statement is like which customer is uh, going for the default on their credit cards or not. We are predicting that one with the machine learning methods like a random forest or uh, logistic regression. So we have selected one data set here. The data set is for the credit card clients in Taiwan from April 2005 to September 2005. So there are 25 variables in that data set. Okay, so the first is the ID, and okay, so this is the data set. If everyone can see, right? Hello, hello.
Yes, yes, we can see.
Yeah, okay. So basically, I am going to give you the features. I mean, what is the features in that data set? So basically, there are 25 variables or features we can say. The first one of is the ID, and the second one is limit balance. That is amount of given credit card in dollars. Okay, includes individual and family and supplementary, all those things. Then sex, that is gender of male or female, and education, marriage, age, page 0 to page 6. Like this page 0 is nothing but repayment status in September 2005. So here you can see that if the -1, then the pay what is that, and for one, like it is delayed for 1 month. Okay, and for 2 it is delayed for 2 months, and for 8 it is delayed for 8 months. So basically, this is our data, like some customer or which customer is delaying how much time to repayment their due. Okay, and this is the bill AMT 1 to 6 is nothing but sorry, AMT 1 to 6. Yeah, that is amount of bill statement in different month like April, May, June, July, August, September. Okay, and this is the amount of previous payment, that is from also April to April to September. And this is our class. We are basically we are classifying this or so this is our class, like 1 equals to yes or 0 equals to no. Like default payment is which customer is going for the default payment, that is for 1. I mean, if the customer is yes, then sorry, if the customer is going for the default payment, then it is 1, and if the customer is not going for the default payment, then it is 0. Okay, so this is our data set. Okay, and I'll share this. Okay, just give me a minute. I'll share this later. First, go through the notebooks. Okay, so everyone in Google Colab or someone using Anaconda or PyCharm, something like that. Hello? Hello? Hello?
You are audible, sir.
Yes, we are using Google Colab.
Yeah, okay. And don't call me sir, please. Okay, so basically, at first we are importing these packages. Okay, so what you have to do is you have to predict the which customer is going to for going for the default payment and which customer is not. So we are importing here packages, different types of packages like NumPy, Pandas, Escalon, Matplotlib, Seaborn, uh, with that trend test, pleat, classification report, confusion metrics, accuracy score, AUC, ROC curve, all those things. And we are implementing, I mean, we will implement some visualization from this data set, that is through Seaborn or Matplotlib. Okay, and this is our model function, like linear model. From linear model we are selecting the logistic regression, and the this is the SVM support vector machine, and this is the special part of regression. Not, this is not regression, this is a classifying. I mean, we are classifying, right? So basically this is a support vector classifier, and this is a random forest classifier. Okay, so what you can do is you can upload your dataset in Drive, and you can mount your Drive in that Google Colab, and you can directly access your dataset from there, as Dipjyoti sir learned you, I mean told you. Okay, and what we can do is we just upload from our local machine to this session, like this one. Okay, so I have already uploaded this. So now we are reading the data set through the pandas data frame, like pt.read CSV. This is a CSV file. So the CSV, I mean pt.read CSV file is used for reading a CSV file in data frame. And okay, so okay, so this is our data set. Okay, and in Google Colab you can explore more by clicking on this. Okay, you can use filters also. These are all features of Google Colab. And after that, we are saying that the dataset info, our dataset information, like for every column, how much value are there, all those things, and their types, like ID, limit, balance, sex, education, marriage, age, pay 0 to pay 6, bill, AMT, all those things. So we can see that there is no null present here. Every column is non-null, and we can see that our data type is int 64, and all except ID, and all are float 64. So here we are checking basically the categorical data, like for sex, education, and marriage. Do you know what is categorical data? Anyone?
Yeah.
Yeah. So the sex, education, and marriage, these are all categorical data, right? But we have present here it as a float value, but we are considering them as a categorical to see just value of them. Okay. So this is our value. Like for there are we can see that for sex, education, and marriage. After
Okay.
that, yeah, after that, we are plotting the data like with SNS Seaborn bar plot that is for default payment next month in the x-axis, and y-axis is value counts. That is how much default is there in the data set and how much default is not there in the I mean how much not default is there in that data set. So this is our data. You can see, this is a you can understand the class imbalanced or class problem here. Like one is so much less than from class zero, right? Right. So basically, this is a class imbalance problem, and it is what in the credit card section happening because for the default thing and all those fraud detection, they are small in amount which are happening in all the transaction. So that is one of the challenge for this detection for default of credit card or credit card fraud detection. Okay. And here we are creating one more plot like default payment with the default payment like classifying 0 or 1, and for 0 what is the number of male or female, and not number, like it is a bar bar plot. So we can visualize the data set in more efficient manner, like for default payment next month for every class what is the sex ratio there, like male and female. Okay. And this is for the graduate school, the education, graduate, university, high school, others, or unknown, something like that. Okay. So here you can see that for corresponding to the classifying problem, like default, which one is default or not, and the sex, not sex, it is education. Should. Okay. And do you know what is cross tab? This one thing. Anyone? Like here we did the cross step from the data, the default payment next month, and between uh, default payment next month and education. Do you know what is cross step? Okay, so cross tab is a simple cross tabulation, like two or more of two or more factors or features, you can say. And by default it computes a frequency table of the factors. Okay. So here we are doing that, and this cross tab is helping us to, we are creating the cross tab and plotting that using this bar plot. Okay. And same thing we did here for the class and marriage. Okay. This one, and currently this is the limit balance, and the distribution we can understand the distribution of limit balance. So here we can, yeah, we can do this for any features, but I am creating just for only one, that is limit balance. Okay. And after that, this is the distribution of age in the data set. So you can always look into these parts of the data set, like which features or which column is in which distribution and how much distribution they have, like if the features is on right skewed distribution or left skewed distribution, all those things. So, and we are creating a correlation map here to understand the data, that is how much they are correlated to another. So this is the we are using Seaborn here, and this is called a heat map. There is a special feature in Seaborn to visualize this correlation map, like heat map. And here are our columns we have selected: page 0 to page 6, and sex, education, marriage, and the class. Okay, and the correlation method is Spearman correlation. So here is the correlation matrix you can see, and from here you can understand the which feature is how much correlated to the other feature, like if it's negatively correlated or positively correlated. Now going into the part of the modeling, or I mean basically the trend test dividation of the data set. So uh, this is the y of our data set. Like we are classifying this one, right? This is our class, the which customer is going for the default and which customer is going not for default. So, and we are considering all those things, I mean all those features, and in the AX and in the Y just class levels. So if we run that, and this is a special function from sklearn, as you can see from here, that is trend test split, sklearn dot model selection import trend test split. So basically what it does, it is I mean it creates a trend test split, like how much of the data will be used for training and how much of the data will be used for testing. So I am selecting here test size is 0.2. So basically in our total data, that is 100%, and the 20% of that data will be used for test size, I mean testing, and the other 80% and the other 80% will be used for training. Okay, and this is the one thing, like pipeline, and we are using this for the standard scalar. Like you can see here, the value is not, I mean suppose if we do the regression thing, like 2 here is 2 2 1 minus 2 and all those things, and suddenly there are big values there here: 2682 1725 133, sorry 13559. So these are big values related to this. So basically what we did here standard scaling. So we can train our model into more efficient manner. Okay, and maybe sometimes it happens that if you directly use these values with these values, then maybe model is to be biased. So basically uh, sometimes we have to do this standard scaling, and we are doing this from this pipeline, and using the standard scalar method. Okay, so we are standardizing our data set in xtrain. Okay, now you can see that everything is like -1 to 1, and we are again doing it for x test, for test data set. Okay, now coming to the model. So this is our logistic regression model, and here is the function we are putting into the logistic regression in log, and we are just creating log. We are just writing here log dot fit xtrain and ytrain. So basically, we are training the model using our training data set, and after that, we'll predict our this log model with the from the x test, I mean x test, the test data set, and we will print the accuracy score. The accuracy score is calculated between y test and prediction by the model. Just a second. You just give me a minute. I'll look into this. Let's. The same thing we are doing here for random forest classifier, and we are fitting the data set and all those prediction. The same thing which I told for the logistic regression. I think something. Yeah. So that is some problem. I mean, when I tried to upload once more the UCI credit card to show you, maybe there is some mismatch. So that's why. So you can see the accuracy here. It will be 80%, and the confusion matrix for this logistic regression is this one. Okay, and the same thing is we are doing for the random forest classifier. Can you know? I mean, do you know what is random state here? Anyone?
Um, yep, yep.
Yeah. Yeah, tell me. Hello.
It's a hyperparameter to what you say to split your data, if I'm not wrong.
Yeah, and you can also like say that it is a random state, like a fixed value that will guarantee you the same sequence of random number is generated each time you run the code. Okay, so it will be
Okay.
fixed. Okay, so it will take some time. Okay, fast. So here you can see that the our accuracy that is 81% or approximately 82% we can say, and the confusion matrix between the y test and prediction, and this is for random forest classifier. This is for logistic regression, and last thing we are doing that k neighbors KNN classifier. So the same thing we did here, X train, we are fitting our model with the train data set, and prediction for is on the X test data set and the accuracy core and the also the confusion matrix. So for the classification task, the confusion matrix is one of the main important thing, and this is nothing but I am again just run all those things and just uh, and just put it in a better manner. So you can see that the precision recall F1 score all the and the support here, and the default no default yes, all those things accuracy for your classification metrics. Okay. So I'm sharing with you the data set, and can you please try to do this? I mean, nothing much, but just explore the data set and I mean, just create some plots on the data set, and after that, you can try 2 or 3 model like this from here: logistic regression or random forest classifier or Canaan classifier. So just try. Okay.
Okay.
Yeah. Okay.
I think so. It's already shared, right, in Drive.
No, I think. I mean,
Okay.
no, no. I'm sharing with you the data set with you. Yeah, I have shared a Google Drive link. Please let me know if you are able to download it or not. Okay.
Okay.
Yeah.
Yeah. Download it.
Yeah. Okay. Everyone, please try.
Akash, are you sharing your screen? Or all are working on the project?
No, I'm not sharing my screen. I just said to replicate that. I mean, just
Okay.
try with some logistic regression and okay.
In case if anyone
I'm
is getting you, they can reach out. They can ping or raise hand.
Sorry, Krishna.
So what I'm saying is that they, in the group, right? If anyone is facing any issue, right? Maybe they can raise this hand, right? There is.
Yeah, yeah, okay. Yeah, sure.
Yeah. Thanks, man.
Yeah, thank you.
But I think it's good that somebody shares the screen and do it so that everyone can see. Or if you,
Yeah.
Rajanna, who is leading from the team?
Yeah. Maybe if like whoever is trying, right? Share the screen so that myself and Akash can check it.
Okay. Thanks, Shankar.
I've already executed it.
Yeah. So this maybe this is the objective is not to just execute this this.
I know. I'm just going. I've gone through
Uh,
the thing.
Correct. Correct. And in that, if you try to do some changes, right? Because now you know that you're approaching this problem, right? Try to put your brain and try to introduce few steps, right? So that way, what will happen is, if in that process, if you're getting any doubt, right, we can help.
Uh-huh.
This will work. I know that this will work. Okay. So,
Right.
okay.
No, I got your point. I got your point. there's some feature, right? To means hyperparameter, we can add additional hyperparameters to increase the accuracy. I'm not recollecting it. Uh, so
Uh,
Akash, are you aware of that?
yes, yes. You can update. I mean, you can update in that, like for logistic regression and all those things. But you need to have understand the proper dataset distribution to update all those things because you couldn't blindly update that, right?
No, no, I know that thing. I know. See,
Okay,
so as
and yeah, tell me.
tell me, please go ahead.
Yeah, no, I mean, I just okay. So basically, do you know the difference between standard scaling and min max scaling?
Not much, I would say.
Okay, so what you can try is just I mean, I did the standard scaler, right?
Mhm.
So can you try that on min max scaler
Okay,
and just print the data set like xten and xtest and sorry, yeah, xten and xtest, and just tell me that what is the difference between that two scalar, and one more thing that why feature scaling is important.
okay.
Yeah.
I just do over here only. For the data set name, what you have taken, DF. It would be DF, right? Data.
Yeah, I'm taking just data as data.
Just verifying the data is proper or not. Have I missed this? I don't have to do ADA over here. ADA is already done, right? Uh,
uh Not here. You can see that
no,
in trend test split, right?
yeah, yeah. No, that's what it means. I'm just checking where is that. Yeah, you have taken standard scale.
Yeah.
Check whether data is really copied properly. What are taken over here? Means given you have taken pipeline standard scale processing main max.
You can skip also that pipeline things. Okay,
Yeah, yeah.
just do it in your own manner.
So it's a scale and part. I'm not getting that code link actually. Yeah, scale and code for yeah. That's one. This is super scalar directly. I don't want to. This is standard only. Main max scalar. Yeah. That all I love it is I think यही ना देखा दिवचून आणि बंद करते डोनेशन नहीं बंद करते ना खाते अननेसेसरी कॉल येत राहतले ते काय कोणाका
Just one thing. You are doing this for all the data set actually.
yeah
Yeah, I'm.
you, you
But
have to look yeah copied that thing na okay I had not copied this one.
no. The thing is, you have to do it for like for training purpose, right? I mean, you are
Yeah,
scaling all those features for that model training purpose. So you should have to do that on X train or X test. I mean, on both actually.
okay this one and
I
this
mean,
one
you are
right
taking that data. Yes, you are taking that data and you are splitting that data set into training data set and other one is testing data set. So you are training
right
like from X train and Y train. So X train is your features and Y train is your classification levels.
yeah I just copied that thing but I didn't got it training data set
That is no problem. Yeah, okay.
I have given it this sample directly given the samples over here normally we use that x test or x this thing no y test uh,
X test and X train. So what you can do, can you go to the Jupyter notebook?
yeah
Yeah, so just read the data set once again.
yeah
Yeah,
this one
okay. And now do the splitting, train test split part.
trend to test split part is already done I've just okay this one again we
Yeah,
already done
already
that
done, but okay. And
you want,
here,
you want to execute that thing again one sec
yeah, you can execute as many times you want. It is no problem.
yeah
Okay, so what you can do is like you are scaling the feature for training, right?
right
Okay, so the thing is, I mean, you have to fit in that scaling part, you have to fit which data? The one
Okay, okay,
that, yeah, the training one data, right?
right.
Yeah. So there should be X train and
Model scale data, model of
or you what you can do, just I'm giving you a line, okay, so you can understand. Send it on chat.
Okay, 1 second. Let me go through it. It is showing model fit extrain I trained over here, and what part I missed? I've not added Y train over here. Scalar dot fit.
Uh,
Fit check. What is MMS for? Okay.
yeah, it should MMS. Yeah.
Yeah, yeah. So what was this? So this is fit and this is transform. So you have used fit
Yes.
transform. Okay.
Yes.
X
Yes.
train
Yes.
and X test. Okay.
Because Y train and Y test are class levels, so we don't have to any feature scaling needed there, right?
Yeah.
Did you run it?
Yep.
Yeah, and extend, you ran it, right?
Yep.
Okay. So basically, can you tell me the difference between the standard scaling and min-max scaling?
1 sec. I'll tell you again. Mm, Standard string actually it follows the SND part, standard normal distribution, which makes mean is equal to 0. Okay. Whereas mean max is a difference between uh, how to say, it rescales your data set in the range of 0 to 1. Okay, and it shows a scaling compressor and was a means how it would, your numbers would be transformed. How to transform your numbers. That's the thing. Means it actually compresses your numbers. That's what I means I am aware of. Min max. I'm not gone through min max much, so that part I can only explain you. Am I right or am I completely wrong?
No, no, you are right. So basically, what you can see that, I mean, you are right that standard scaling does the standard normal distribution of the data. Like you said that mean zero and unit variance, right?
Yeah,
Yeah. And min-max scaling is
rescales the
nothing.
data set.
Sorry.
It rescales the data set with the features of range to 0 to 1.
Yes. Yes. You are right. So you tried before the standard scaling and trained the model, right? And can you again run that model on the min-max scaling? I mean, with the help of min-max scaling of that features.
No,
So
no.
we can see the
What you want to
difference,
say?
right?
Okay.
Just run
You
any
want to say
model.
actually?
Like we have trained it before with the feature scaling with the help of which one? The standard scaler, right? Yeah,
Right.
now we are doing the min-max scaling, and now we want to ensure that, I mean, we want to check that is there any difference when, I mean, on that data set for the feature scaling?
Yeah. So I'll just
Yeah,
copy paste this thing, right?
just copy logistic regression or anyone.
Yeah. 1 second. I'm just seeing where. Okay. Here it is. I don't want to disturb that part.
Yeah, and print it. So there is a little difference, I think.
That's what I'm seeing. One second, let me check. Yeah, little bit more.
So
0.8. Sorry,
yeah,
81 4, and it's 81.
yeah. So basically 80%, and we can see that if we use the min-max scaling, the difference is like 1% accuracy of, right?
Right. Yep.
Yeah. So that is one of the important thing of feature scaling. I mean, and the one thing is required to understand that when we have to use which scaling method, and is there really required to scaling the features. Okay.
Okay.
So basically, I mean, here we are rescaling the features because of that. I told you now that the I mean, which are those features like bill AMT to bill AMT6 and pay AMT1 to pay AMT6. Those are really big
BAMT.
values, right?
Could you please repeat again? BAMT.
No, that is bill amount.
Okay. Okay. Okay.
Yeah, the features there are bill amount and payment amount, right? So they are
Okay.
really big features like 11,000, 38,000, and
Right.
related to that, the month we are delaying for the amount due on the credit card, they are so small, 2, 1, -1, 0.
Right. Right.
So yeah, so when we're trying to do any classification model or regression model, there maybe it can be happen that the model will go to onto the big values. I mean biased on towards the big values. So basically that's why we are using that feature scaling. Okay.
Okay. So as to reduce the number to certain range. Okay, and so that we can what to say, classify it properly, or we can just
Yes.
get a
Yes.
more accuracy level. Got you.
Yeah.
I got you. Thanks.
Okay. And one more thing,
Hmm.
you are saying about that more functionality hyperparameter tuning. Like at first, do you know? I mean, logistic regression. I mean, I mean, this is a regression problem. I mean, this is a classification problem, right?
Hmm.
And we are doing this via a regression. I mean, named in a regression, logistic regression, right? So
Right.
basically, the regression problem and classification problem are different. So can you tell me why? I mean, why can we use that model? I mean, logistic regression model as a classification model. How?
Logistic regression goes to 0 to 1 range. Being a regression, it has features, or it has a what to say, functionality to make it a 0 to 1. I would say the question is that question should be why we call logistic regression as a regression and we use it for classification,
Mm-hmm.
right?
Yeah.
That should be a question, if I'm not wrong.
Yes.
Um, like how to tell you that thing. But yeah, that one thing what I mentioned is that its range to target value is of 0 to 1, and it's a it takes a probability of your target value, means whatever value is there, output value is there. We try to get the probability. Okay. Yeah. That's what I can see. Uh, oh yeah.
Yeah, you are right. Actually. So basically,
Yeah, but it's not complete. If not, it's a complete answer, right? So could you please
yes,
elaborate,
yes.
means, give it a complete one?
Yeah, the thing is, I mean, the basic simple function we are using in logistic regression, that is f of x equals to 1 by 1 plus e to the power minus x, right?
Right, right,
Yeah, so basically that goes to, yes, 0 to 1. And suppose if we have to classify something, then we are setting a parameter like if suppose you are classifying that if this is a dog or not, okay, using logistic regression, and you use the function, you input, you train the model, okay, and you are setting a parameter like if our train data is I mean, if our prediction will be upper from 0.7 or 0.8, I mean, whichever value you want to give there. So basically, if our prediction value will be 0.7, then it will be set as a class 1, and if it is less than 0.7, then it will be class as a 0.
Okay. Okay.
Yeah, did you understand?
Yeah, yeah.
Yeah, so that is the thing, I mean, logistic regression. And
In short,
there are,
you can say that logistical regression is a supervised learning algorithm which is used to classify, solve your classification problem of binary issues, binary problem, which is 0 to 1, right?
yes, yes.
Gotcha. We were over here, right?
Yes, and
79%. Yeah.
one more thing,
Right, yes.
that is, you are talking about the hyperparameter tuning. So basically, can you go to the scale and logistic regression page?
Which one?
Scale and logistic regression function page. I mean,
Okay, okay, okay,
yeah.
okay. Got it. Right.
Yeah, so here you can see that at first there is called penalty L2. Yeah, and you can use L2, L1 elastic net or none, right? And default is L2. So do you know what is L2?
L2.
Yeah, I mean, you can see that penalty is L2 default. By
Okay.
default it is L2, right?
Right.
But we select L1 and L2 as a penalty term. But I mean, do you know what is these things?
No.
Okay. So basically, the thing is, there is a topic, not topic, but there is a one thing that is called bias variance trade-off. Okay. So we like, I mean, the deviation of the function is varied like on bias variance, and like, do you know what is bias? Bias is the measurement of the deviation or error from the real value of function, right?
Exactly. Right.
Yeah. So basically, just a second. Just a second. Yeah.
What would be underfitting? What would be overfitting?
Mm, yeah. Okay. I'm sorry. So, L1 and L2. So basically, that is called a regularization method. Okay.
Okay.
And L1 is called for lasso regression, and L2 is called for ridge regression.
Mhm.
These are all the, I mean, more prone to theoretical part. But
Yeah, yeah. I know that thing, but it's a long time since I have not gone through it, so I am aware of lasso and which. But
hmm.
yeah.
So what you can do is you can try with penalty as L1 for logistic regression. Yeah, you tried with min-max scaling, and you can try now with penalty as a L1 regression. I mean, L1 regularization.
With logistic. Isn't it only right? LGB is suppose only L2. Let's check the plan. PC has reduced. Uh, why L1 was not used over here? Where it was given? For LGBS. Are you aware of this one? LTB linear?
Yeah, I mean, just try.
It has increased. One more additional thing. Now, what's the meaning of lib linear has to be checked.
Sorry, which one?
Solver.
Okay, so solver is like a linear classification. Okay, so I mean, it is a there is an algorithm called coordinate descent. Okay, so that is basically
Coordinate.
sorry,
Come again. There's an algorithm called
coordinate descent. Like gradient descent is there,
gradient descent. Okay, gradient descent. Okay,
not gradient
yeah,
descent. Yeah, it's coordinate descent.
coordinate descent. Okay, I've heard of gradient. Okay, yeah, please go ahead.
So basically, that is the optimization thing. So I
Okay,
mean,
tuning
uh,
part.
th-
Okay,
yeah, these all things, lib linear, and there are many things. I mean, this is for, I think this is for binary classification, and there is one for also multi-class classification. So you can use those optimization algorithm to train in more efficient way. That's the thing.
got you, got you, got you. I'll surely look into this thing. I was not aware of this part, solver and penalty. I'll surely look into it. I was just using the default logistic regression. Yep. Let's check if there is
Yeah.
something else.
Just one thing. I mean, before checking that L1, L2, just check. I mean, just read once that bias variance trade-off. Okay.
Yep, yep.
Yeah. Okay.
Okay, anything more we should do on this one? Because accuracy level has slightly increased using this penalty. Uh, let's check what was the penalty.
Yeah, you can try with random forest classifier, right? With hyperparameter of random forest classifier.
Shuffling, sample, purity. Difference in high keys, calculator use, calculator.
Okay. Do you know what is this entropy?
There is a lot of background noise, so I can't open my this thing.
Yeah,
I think.
that's
Yeah.
that's completely okay. Anyone? What is entropy? Okay. So
It's
basically,
both entropy and if I'm not wrong, entropy and Guinea are nearly same. Only difference what I found is that entropy is range from 0 to 1, whereas Guinea is range from 0 to 0.5.
yeah, I think. I mean, I didn't remember the range actually. Sorry. But
Yeah.
one thing is like entropy is the randomness of the, I mean, of the information. That is what you can say. This is a entropy is the kind of a metric that measures the unpredictability or impurity in the system. Like if you have a data and how much the data is pure. Okay. How much is I mean, if that is very impure or less impure, something like this. I mean, can you search that? I mean, you can find that in Google and there will be some image, so that will be better to understand.
Yeah, it's the same thing. Guinea impurity and log loss. What's it? I'll just search over here.
Can you just go in
Sorry.
some image? Yeah, click on Geeks for Geeks. Can you open that?
This is Git project. I have opened the Git project and
Is
let's
there
check
any?
for images.
Yeah, no, that's not. Okay, so impurity criteria is there, right? Gain index and entropy.
Where you're finding that? Okay.
Down. Not this one,
Down.
actually. The image, yeah, this one. Yeah, this one. No, this one.
This is just a formula.
Yeah. So basically,
You want a formula or you want this one?
no, actually, I'm wanting some image of information impurity, so you can visualize that thing.
Okay.
This one.
Yeah, 0.5 and 1.
Yeah,
It was right.
you are right. Yes.
Two legs once. This one is not. This is meant how to do that thing. This is a decision tree classifier that would help. They mention how to do it.
Yeah. Okay.
Nothing
I
else.
found.
If you have that, means yeah,
Yeah,
one.
this one. Here you can
This one,
visualize, right?
sorry.
I mean, I'm saying that here you can visualize that what is
Yeah.
impure and pure of the.
Right. Okay.
Yeah,
Okay. Total,
that's
totally pure and more impure. Yeah. Got you.
yeah, that is the thing, and we are calculating this thing. I mean, like information. There is something called thing called information gain. So basically, and Gini and entropy both are measures of a impurity of a node. I mean, how much it is pure or how much it is impure. Okay, so we are. We know that part from Gini or Gini and entropy. That is a measure of impurity of a node. If we this is a decision tree, right? A
Right.
random forest classifier. So basically, we are checking that impurity of every node with that Gini and entropy. That's it. And that is 0 0.5 and 0 to 1. And the thing is actually, I got it. I got your point actually. So basically, that is from the formula. If you see the formula of the Gini, then it is like 1 minus something summation of PCI, something like that, right?
Right.
Yeah.
Yeah.
So
This one.
Gini will always be less than 1, right?
Right.
Yeah.
Okay. Let's go ahead for this one. If I'm reducing it. Nothing changes. There is no much difference in that. Uh, just check for gain average level. Reduce KD tree and root. Check. That tells you same thing maybe. Are you aware of DB scan? Uh, there's one more algorithm, is there, right? DB scan. Um, Akash, right?
Am I
Akash?
audible? Sorry, I was speaking on mute. And DB scan is clustering based algorithm, right?
Yeah. I'm not using over here for one of the thing I required that part. Okay.
Okay. So, I mean, DB scan is
Yeah.
like unsupervised model. Okay, and that is we
Supervised.
use for. Sorry.
No, no, no. Please go ahead. Please go ahead.
Yeah. No. I mean, you say something. I didn't hear you properly.
No, no, nothing. Means in one of my project, I wanted a DB scan. As I was going through the documentation in morning only. So that's the reason I've asked. Nothing else. Yeah. Please
Okay.
ignore.
So DB scan is unsupervised, right?
Yeah.
Yeah. So basically, we are using their spatial clustering of the data to.
Right.
Yes. I mean, what you want to know about that?
No, no, nothing. Actually, I had some coordinates and I had to means group that coordinates according to the right position. Means which comes to left, which comes to right. Means I'm trying to locate the maps of India. Okay, so accordingly, means which location is located where as per the coordinates. I was trying to plot that thing. So someone mentioned me to check for DB scan. So that's the reason I was just going through it. So uh, it just struck my mind and I just asked you. Nothing else. Ignore. Just ignore it.
Yeah, okay, okay.
Shall we go ahead with the further process of this part?
Which one?
Are we going to do only this one, or we are trying to deploy it also on a server, like what the previous one has done? I forgot his name.
Yeah,
Devajit. Yeah,
Yeah.
yeah.
So no, we are not deploying, but we are more prone to. I mean, for today, we are more prone to these machine learning skills. So
Okay.
everyone tried or just you? And can anyone show me like standard scalar to min max scalar or something like that? Anyone? Okay. Okay. So, yeah, Shankar.
Yeah.
Shankar. Okay. Then one thing. I mean, we can go to the explore the data set a little bit more. Okay. So, can you plot the whole data set for a correlation map? I mean, correlation map for the whole data set.
Okay. One second.
You can just try. And everyone knows about that. What is correlation, right?
Yep.
Yeah.
I think so. will take little time.
Sorry.
It will take. I'm saying it will take little time.
Yeah, okay, no problem. You can try.
How much value it has actually? Columns. It's 25 columns.
Yes. And I mean, you can do that for df.info to get the information of the whole data.
Sorry, come again.
df.info. D. Sorry. What is the data set? That is data, right?
Data.
Yeah, okay. Then data.
No, I've viewed it on top. Yeah, this is a correlation.
Okay. That is Pearson's. Okay. Can you plot the heat map with the
Heat map
values?
is one second. Heat map should be there. Oh, yeah, one second. Let me check.
Yeah, just
Heat
go
map
up
should be there.
little.
No, heat map is not there.
Yeah, okay. So just go a little bit up. I mean, in the notebook.
Okay.
So a little bit up. I mean, there is a heat map, right? Of correlation of some columns. Yeah, this
Right.
one. Yeah. Can you plot this one for whole? I mean, for whole data.
You want to plot what means this data for this one?
Yeah, this heat map. Yes. I mean, this heat
No.
map, all those data for all those columns
Uh,
present in the data.
no, you want to do profiling for this one, like what I've done now for correlation of this part, or
No. I mean, for every column of the data, you just have to plot this heat map. I mean, here just 8 to 9 column, right?
right?
Yeah. So I want to you do that for whole of the data. Just type.
Okay, whole data set. Okay. Mm, that's something. Data bar only. run it again. It's taking too much time.
Yeah, okay. I'm giving you the
बैंका से लेकर बोरोली तक वो रेंज के अंदर वहाँ हैगा तो ही बताइए.
sorry, your voice is not clear actually.
No, there was spam call. It's taking too much time. The data is used, 25.
Okay, it is running, right?
Yeah, it's still running. That's the thing.
Okay, okay.
I don't think so. It would give that output so quickly.
Yeah, you can stop it
How to stop this one?
and just try with little bit less
Interpret.
parameters.
Won't work.
Yeah, it will not stop.
Hello. Won't stop. I
Yeah,
have to restart.
yeah, just stop.
Okay, good. It's working. Let's check for. Let's check this one. This output. Yeah. Yeah. This one is your heat map.
Yeah,
Akash?
yes. Yeah, am I audible?
Yeah.
Yeah, this one. Okay, so just can you try decision tree classifier?
Okay.
Yeah. Yeah, for training the model.
Both are same, right? Just click. I don't have to keep random state over here. Main thing I have to keep the guinea would be the basic part over here. Uh,
Sorry, are you?
Sorry?
Yeah, I mean, did you say something?
No.
Yeah, okay, okay. Sorry.
Not. I don't want to keep it brief and all this one. So now if I train, predict, and your prediction is done. Rest remains the same. This one is already done, right? I don't have to input it. Add this criteria.
Open time.
Sorry?
Just said that, yeah, you can try with those parameters.
Yeah. Yeah. So when I had taken a random state opportunity, accuracy was too less. As soon as I increased that, added that parameters, additional parameters. So here also there's a same entropy is there. So features, features.
Yeah, you can, what you can do, you can increase the max depth there. And can you see what will happen? Just, yeah, just make it 20.
Sorry?
I mean, max depth as 20.
Just reduced.
Yeah, and can you try with, yeah, okay.
One second. Hello, who's hello? Sorry, there is one.
Yeah, no, no, it's okay.
Max feature, which is root. So it's 7. Whereas when it was 5, it was giving accurate, too accurate result. So have to check means, on what basis this parameters are increasing. Means even if I am showing a less depth, it's providing me a more accurate result as compared to the if I'm increasing it to 25 to 20.
Okay. I mean, here we can do one thing like we are setting parameters grid. I mean, suppose you can't check this every time, right? I mean, making it
Right,
5 and making other 10, all
right,
those things.
right,
Yeah.
right.
So you can make a generate, I mean, a general function to take all those things. Like if you want, I mean, in the first trend, I mean, in the first training, if you want the max step that's 5, or in the second training max depth as 50, and all those hyperparameters, I mean criteria guinea or something like that, anything. So you can train that way also. So what that will do is like, I mean, in every step they will training with that particular hyperparameter, so you don't have to check every time.
Okay, you want to write a function for that where I can use a for loop or while loop, sorry, to check the range between 0 to 20, 1 to 5 to 20, and whichever is the highest, I can just provide output to you. So that this is a output and this is a depth. What is the max, which would be providing the maximum output. You are saying that way, right? Write a customized function.
Yes, 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 you can do that. I mean, not now, but you can do that. So that will train one by one, okay, with all of those parameters.
Yeah,
Yeah, and but
even that has to be. Yeah,
mhm. Just
yeah,
one thing, I
please.
mean, yeah, tell me.
Yeah, please go ahead.
Yeah, no, I just want to check someone's notebook. I mean, if how much they are processed, I mean, how much they are in, how
Guys,
much,
are you there?
how
Uh,
much they progress.
they are expert. All my team members are expert except me.
Yeah, that's okay. I mean, anyone can share, please. Rajan, Vinaya, anyone? Hello, am I audible? Hello. Hello.
Yeah, Akash.
Yeah, I mean, anyone can share their screen, right? I mean, you did lots of things, so.
Yeah, 1 second. So I think, sir, Dinsi, there is share issue. Could you please uh, provide us the option to share? Hello, am I audible?
Yes.
Okay, Akash, min-max color, my accuracy has been reduced.
Yeah, you can share your screen actually.
Let me check.
I think there is a network issue, if I'm not wrong.
Can you see it?
Yes, it's visible now.
And it standard scalar. No, min-max scalar. Previously, 81 is almost the same. Logistic regression, but
But I mean, can't see your notebook.
can you see now?
No, anyone can see? I'm seeing your screen, but that is analytics Vidya.
Okay. No,
Yeah, now it's visible.
maybe a different screen. I applied, I mean, it's previous one. Standard. I applied the min-max scalar, remaining X train, Y train. I run the logistic regression. Previously, it's almost logistic regression is the same, but I didn't apply any parameters. Yeah, parameter nothing. Even the confusion matter we look out. Again and all. I mean, it's a minor changes in accuracy, precision, and record. Not much when I change it to the min-max scalar.
Yeah, the thing is, what happens? I mean, you are didn't set any random state or something like that. So when you train this, it can happen that can you try it once again to train logistic?
Okay. Yes. Scalar is like 8 almost 10%.
Yeah, here is same.
Do you want me to change any parameters?
Yeah, you can do. But the thing is, I mean, what I'm telling that sometimes depends upon the data set and you are scaling that. So basically what happens when you are fitting that into the model, so sometimes it will slightly change their thing. So
No, it's already changed. Slight change. It's not like prior to that. It's different. One. Let me check. Maybe
I didn't get you. I mean, can
see. When I look for the 1 second, let me run with a standard scalar.
Mhm.
Oh, it's almost the same. No change. 81%
Yeah.
standard scalar.
But if you round it off, then it will 81 and
Yes.
82. But it's okay. I mean, it happens sometimes.
Maybe I need to do a.
Like,
I mean, yes, I do understand. The data set is almost the same, right? Maybe I need to fine tune the data set.
mhm. Or what you can do is just add some parameters.
Parameters you want me to.
Yeah, in the logistic regression, just add some parameters. Then see. you added? Hello.
Yeah, I'm doing it.
Yeah, okay. Have you completed it? Hello? Did you change? Hello? Am I audible? Hello?
Yes, sir, you're audible.
Yeah. I mean, did you change? I don't know who is presenting that time.
Suresh, Suresh.
Okay, okay. Suresh, did you change that?
Suresh, you're on mute. Maybe.
There is some network issue at his end, so he's getting disconnected frequently.
Okay, okay. That's okay. Anyone want to share their screen or any doubt? Okay, and just one thing. I mean, you guys are heard of the artificial neural network, right?
Network, I heard of. Yeah, correct.
Sorry, Rajanna.
Neural network, right? Neural network. Yeah.
Yeah, neural network.
Correct.
Okay. So actually, I mean, are you interested in that?
Yeah, please.
Yeah. So basically, I mean, what we are doing here with the class, I mean, the classification problem with all, sorry, decision tree, random forest, and logistic regression, all those things, we can do the similar thing in neural network. Okay, by using, and I'm sharing my screen. Okay.
Sure, sure.
Is it visible now?
Yeah, it's visible, sir. Yeah.
Okay. So the same thing. I mean, we are sorry, we are reading the data, and suppose if we did all those things, the data set info and the categorical data and the plotting correlation.
Your voice is too low, actually.
Now it's okay.
Yeah, no, better.
Yeah, okay. So the thing is, I mean, we have completed all those things, right? I mean, this plotting data, you can try this with like, here it's default payment next month, education. You can try here this with age or marriage, whatever you want. Okay, in that data set, you can try to plot all those things. And I'm not rerunning all these cells, but just these cells. Okay, I did the trend test split here. Okay, and the scaling also, min max scaling, right? Because it is MMS equals to min max scalar here, and I did the min max scaling right here. Okay, and X test. But now we are going to this data. I mean, now we are going to feed this data into the neural network. So, I mean, what do you know about the neural network? Anything? I mean, anything?
So neural network, actually, here we don't have to do like no feature engineering. Pretty much it does, it itself as long as we give X and Y data. So there is a no.
I didn't get you actually. I mean,
No, no, actually, no, deep learning or maybe the neural network. Here, normally, the machine learning, we try to do feature engineering. We create a data and then we'll put it onto the you know, with the model actually for classification model. And normally, neural network, as long as you have that input, the data, and right x and y, we can run through that neurons like flattened layer, and we can create internally in with few layers, and we can get the, at least to some extent we can get the required model. We can make a model.
Okay, just one thing. I mean, when you are passing that data into a neuron, okay,
Mhm.
what happens really there?
Between the neural, it will create a weight actually when we like no it try when we pass on the data for like no in a sense all, if you have a uh, um, 5 columns or something we pass, and these output we expect it's try to correct itself internally, like it's a multiplication actually happens between different layers, and as long as it gets the corrected output, it keeps changing it, the weights of the neural weights, it keeps changing.
Yes, and which algorithm?
Your voice is too low again, Immense.
Sorry. I'm saying that which algorithm we use to do that.
Oh,
I mean,
algorithm, huh?
optimization thing.
Okay, okay.
Yeah,
Normally it's a like no
the simple
backward
basic.
yeah,
Yes, back propagation. Yes,
gap
and
propagation, yeah.
we are using that for the gradient descent also, right?
Correct, correct. It's kind of wherever it's a low loss there, we lock it up together. Yeah.
Yeah, we are trying to find about the loss function. Where is the
Lowest, yeah. Lowest error, rather, lowest loss.
I mean, where is the optimal point in the loss function, right?
Mm, correct.
Okay, so basically this is, I think, I just did it to show you like,
Okay.
yeah. So this is X10, our train data set, 24,000, and there are 23 columns. Okay.
Yeah, right, right.
Yeah, and we are using here TensorFlow. So basically, and the TensorFlow is a deep learning model. Okay, I mean, sorry, deep learning library we used for creating models and training the models. And we using here a sequential model. Sequential model is like there is no gap in between them. Okay, so everything is connected with everything, and we are using here like model.add. There is a layer. Okay, this is all, these are layer like 64, and so you can see here that is the shape is here 64. So basically we are putting all these data set to the neurons. Okay, here 64, 32, sorry, 64, 32, and till 1. So this
Yep.
is our our neural network. This is our last layer, and here I selected activation as sigmoid. So basically, the logistic regression I used. One I said you that now, the simple function of logistic regression is 1/1 plus e to the power minus x. So basically, that function is also called a sigmoid function, and that is also between 0 to 1. So we are using that function here. So this becomes a classification problem.
Correct.
Okay.
Right.
Yeah, and we are compiling this model with this is the optimization algorithm called Adam. With this is a learning rate, and the loss is here binary cross entropy. So basically, this is specifically for binary
Classification two,
classification.
yeah. Two
Yeah,
plus.
binary. Yeah, 2 plus
Correct.
problem, and our matrix is accuracy. Okay, just simple thing. I am not going into the details too much, and we are selecting here that, I mean, we are fitting here our model. The history equals to model dot fit with the train dataset x10 y10, and for epochs equals to 10. Epochs, what is that? That is how much time our whole data will training through the network. Okay, so and our validation data set is x test y test, which are, we, I mean, these two data set will be for validating, I mean, how the model is correct or how much model is correct. And just leave this thing actually, callbacks and all this. Just ignore
Can
these two. Okay. Yeah.
can you please share this file, because I think so the previous one doesn't has this one.
Yeah, yeah, it will not have.
Yeah, I will share this whole file actually.
Okay.
Okay.
Okay, so basically, callbacks is nothing but I mean this is like a regularization technique. Okay, early stopping and callbacks. So I am
Yeah, yeah.
just ignore those things.
Sure,
Okay,
sure. I think we
so
are.
yeah, so we can say here. I mean, we can see that here parameters are there, and total parameters and trainable parameters, because we are training from the scratch, right? We are not using any trained models or nothing. We just write it down and training from the scratch. So I just run it. So here you can say this is you can see this is the epoch 1, and I selected epoch as 10. So the whole data set will go through the whole model 10 times, and you can see here loss, accuracy, and validation loss and validation accuracy. Okay, in every epoch. Okay, so here you can see that the accuracy is 81 or approximately 82%, we can say, and our loss value is this 0.4414. Just
Yeah.
okay, and just one thing, I mean, can you tell me, here is 8179, here is 8092. So why it is, I mean, why 8092 is here? I mean, this is matching with this, not with this one. Why?
No, the one is train accuracy and another one is a test accuracy.
Testing accuracy, yes.
Yeah, right.
Yeah, thanks. So this is the little bit, and I am sharing the link of this. Okay.
Sure.
Okay, I'm just giving you the viewer permission. Okay.
Sure, sure. I
And
think that's
can,
yeah, not an
yeah,
issue.
That's completely fine.
Yeah, I
yeah.
think we I think neural network. I think and, when we were doing it, we were champ, and now we forgotten later.
Yeah, okay.
The only thing is,
Uh,
what is the hyperparameter? That's a big. Remaining everything is a straightforward. That's what I can able to see. The
uh,
That those things
callbacks.
standard, Suresh, in the sense, no, like no learning rate, if you decrease, increase, and like
Yeah,
no
yeah.
back propagation, how far, like no, finer you can go, or so that,
Early stop. Okay, early stopping and everything. Yeah, okay, okay.
yeah, early
Okay.
stopping means it'll
I
keep.
saw only callback. I've seen. No, I didn't see the early
Okay,
stopping.
that is the reason it stopped at the 0.4%. Otherwise,
0.5%.
it could
Yes.
have gone still low, low. It can go in a loop actually
Yeah.
for long time.
It
Yeah,
walked 10 and there is no okay. Iterations we didn't put down.
yeah, yeah, right, right. It can go up to 100% also. At
See,
least
yeah,
see,
that will be
training,
by
training,
100.
multiple
training
trains were done.
accuracy. We can't change the test at least training accuracy. It can go up to 100, right?
Data
Yeah,
set is the
and
straightforward one.
100% will be dangerous for us.
See, data
Yeah.
data set is like that, right?
But deep, no, 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 Surya, actually, no, this deep learning model, especially training, it can train no to the best possible. But obviously, test will be different now. I think it is not trained on test data, so that's why test it will be little lower actually.
Yeah, and training y is equal to f of x, right?
Mm.
That's trained in a proper way. But when it comes to the testing, I mean training, not testing, it will be tougher.
Yeah, yeah, training because yeah, it will be tough because it has not seen the data. It's not trained
Exactly.
under that.
Yeah, and there can be chance of, I mean, suppose the 100% training accuracy, then that can be chance of overfitting.
Yeah.
That will be a very big problem. Yeah, okay. So any question? I
No.
shared the link. Okay.
Could you
Yeah,
speak
yeah,
with the deployment?
Deployment that will happen, I mean, next week, I think. I mean, next session. So That will do Debjyoti sir. And this is all about these the basics of machine learning. I mean basics to intermediate kind of level of machine learning, and a little bit small introduction about the neural network.
Okay.
So, any question, any doubt?
No, we are good at ML and TL.
So,
Akash, I told you, na, means don't compare Shankar with others. Shankar has no knowledge, means he's completely blank.
Ah, ha, ha, ha.
Rest team are expert. Rest teams are expert. Catch Rajan, na, catch Suresh, catch Vinaya, anyone. They are expert.
No, Shankar, not that way. I mean, okay.
No, he's comparing me with you, with you all people. That's the reason I
No,
told you.
I am maybe only I'm seeing Suresh only. Maybe I didn't hear the maybe.
yeah.
Yeah, I came just. I mean, I was.
Voice is low or my speaker is gone. Actually.
No, it's good. I think voice is.
Hey, my speaker is the problem. My camera is the problem here. Don't worry.
कैमरा तो बंद ही है भाई. Okay.
Yeah. So, all okay? No question. Nothing.
No.
No.
Nothing.
Yeah. Okay then.
Thank you.
Okay then. Thank you. Thank you so
Yeah,
much.
thank you very much, Akash. Thank you.
Yeah. Thank you everyone. Yeah.
Thanks,
Thank you.
Akash.
I'm dropping off then.
Yeah, thank you.
Yeah.
Thank you.
Okay. Thank you so much.
Thank
Yeah,
you all.
bye.
Bye.